Very good morning, girls. Once again, I welcome to the online classes of the numerical analysis, and in the last class we discussed the concept of the Lagrange's interpolation and the applications. Now here I on divided differences and their properties. Okay, so now here divided differences means simply see here, write down. Let x0 comma y0 comma x1 comma y1 comma x2 comma y2 and so on xn comma yn be the given n plus 1 points. Then the divided difference is of order 1, 2 and so on n are defined by the relations. Listen carefully. First, divided differences. So first divided difference ela denote chestamante square brackets. First it starts with x0 comma, no need to mention comma also, x0 x1. Okay, if you want then you can mention comma, x0 comma x1. And here remember always this value is what I have, x0 x1. So here reverse, y1 minus y0 by x1, otherwise you know here upper value, lower value. Okay, so this is nothing but x0 comma x1. First divided difference, and of course here it also written as, because we know that y is equal to f of x, right? So here you can mention that for the function y is equal to, then it is also written as f of x1 minus f of x0 by here directly x1 minus x1. I think it is somewhat easy to remember, right? You can easily remember these values. Next, if x1 comma x2 means what you get here, y2 minus y1 by, of course see here it is somewhat now here y2 minus y1 by x2 minus x. Clear? So next x1, x0, x1, x2, next x2, x3. What will be the value? y3 minus y2 by x3 minus x2. So in general, x are otherwise xi comma xi plus 1 is equal to, how we will denote, yi plus 1 minus yi by xi plus 1 minus xi. So this is nothing but the formula for first divided differences, simple thing, and you can put any value here, I is equal to 0, 1, 2 up to so on n. Okay, so this is the first divided difference formula. Okay, I hope you will understand easily. Next, second divided differences. So for the second divided difference, what we get, x0, x1, x2, three values we will get. So then the formula is, listen, first of all we have to take the second and third one, means x1, x2 minus, next what we have to take, actually here what we are taking, upper value, the next lower value. So that's why here x1, x2. Next x0, x1 divided by here. What is the upper value here? x2. And what is the lower value? x0. Like this we have to. So now additionally here it can be, if you want, again here if you want to calculate this value, first of all you have to calculate x1, x2. Next x0, x1. Next directly you have to substitute. Okay. Now x1, x2, x3. What will be the formula? First these two. x2, x3 minus x1, x2. ఎప్పుడైనా గుర్తుపెట్టుకోండి ఇక్కడ లీస్ట్ వస్తుంది, దెన్ నెక్స్ట్ గ్రేటర్ బై x3 minus x1. Next, so on. In general, xi plus 1, xi plus 2 is equal to xi plus 1 comma xi plus 2 minus xi comma xi plus 1 by xi plus 2 minus xi. So this is nothing but the general formula for second order divided differences. Okay, so like this we have to take the formulas, and you can take up to so on like xn also. Okay, sometimes you can take that. The next third derivative will be, what will be the similarly third derivatives are x0, x1, x2, x3, right? Next fourth derivatives, so on. So here what we get simply we will get that x3. So here when you have like this, then you have to take that, you have to leave the first value. Now x1, x2, x3 minus x0, x1, x2 divided by x3 minus x0, so on. Nth divided differences are x0 comma, right, as it is now. N minus 1 x. So these are the divided difference formulas. Okay, so next, in another way the first divided differences are x0 comma x1. Actually here we have this value, no, so we can write it as nothing but simply what I have, which is equal to y1 by x1 minus x0, and here I am taking minus y0 by x1 minus x1. I am taking minus common from the denominator. Then what we get here, we will get that y1 by minus x0 by x1 minus y0 by minus x0 minus x1, right? Otherwise series n. Here one value is positive and one value is negative, no? So y1 by x1 minus x0, here I am taking only for the second term, I am taking minus common. Then what we get, x0 minus x1. So it is minus into minus plus. So y0 by x0 minus x1, y1 by x1 minus x1. So you can write like this also. I think the previous one is easy to remember. Okay, so similarly write as it is, ma, as it is. Similarly for the second divided differences, here we have that y0 by x0 minus x1 into x0 minus x2 plus y2 by x2 minus x0 into x2 minus x1. And generally, similarly, x0, x1, x2 and so on xn is equal to y0 by y1 by x1 minus x0, x1 minus x2 and so on, x1 minus xn. Plus so on, what we get? Next value will be y2 by so on, right? Plus so on. Next value will be y2 by x2 minus x0, so on x2 minus xn, and finally yn, x1 minus xn minus x0, xn minus x1, so on xn minus xn minus 1. These are the similar formulas. And right now, by taking x1 minus x0, x1 minus x0 length anamata. Okay, x1 minus x0 equal to x2 minus x1, all this equal to x3 minus x2 and so on, equal to last value will be xn minus xn minus 1 is equal to h. Then what will be the value of x0 x1 which is equal to y0 by, here what we get, x0 minus x1 means, just now I said that, it is equal to h. So y0 by h plus y1 by h. So we can take that 1 by h common, then simply it is y0 plus y. Okay, so like this we can calculate the value. Okay, and in another way how we can write it as nothing but some delta y0 also and so on. In generally, write down. No need to remember all this. So I gave the first divided difference, second divided in the starting now. You have to remember those. That's it. Here x0, x1 and so on, xn is equal to box it. Okay. Next, Newton's general, put a side Newton's general interpolation formula. So generally here what we know we know that x0 x1 is equal to y1 minus y0 by x1 minus x0, right? So if you want, then you can actually, here what they are saying, Newton's general interpolation. So here we have to find the value of y. So y means, see, generally here we have like this. Now I am taking that x comma x0. Then y minus, here we will get that y0 by x minus x0. Okay, so generally here we have to get that here naught and so on. Meaning of this one is x1 comma y1 is equal to x comma y. Okay, x0 comma x. Clear? So now from this, what will be the y minus y0 x0 comma x into x minus x0. Therefore y is equal to y0 plus x0 comma x into x minus x0. So this is the value of y. So next here we have to find the value of this x minus x0 and we have to substitute. So finally by solving, write as it is. By substituting x0 comma x value and simplifying, we will get the Newton's general interpolation formula. As write as it is now. Y equal to y0 plus first x minus x0. Okay, into x naught comma x naught. Write as it is after that I will explain. Okay, simple thing, listen. Y equal to, y means function value. Okay, Newton's general interpolation formula. First x minus x naught. First divided differences plus x minus x naught into x minus x naught. Next second divided difference and so on. So this is nothing but the formula, you have to remember this one. Okay, so next here we have an application. So already we discussed this application in a previous topic, that is Lagrange's interpolation formula. Right? So I am taking the same example, but here I am going to apply Newton's, here what they mentioned, general interpolation formula. Okay, so that is nothing but write down as our first example of Lagrange's as our first example of Lagrange's, to illustrate the use of Newton's divided difference formula. Newton's divided difference formula. Newton's divided difference formula by taking the given table. So here they gave the table. X values are by the given table. Find the value at x equal to 301. Find the value at x equal to 301. So they gave the table like this: log x base 10, 2.4771, 2.4829, 2.4843, 2.4871. Okay, so next here what we have to calculate? First, divided differences. That means x naught comma x1. Otherwise, simply first divided differences. Listen carefully. First divided difference means what is the formula? Y1 minus, it is nothing but x naught. Now listen carefully. x3, y naught, y1, y2, y3. What is the formula for this first divided difference? y1 minus y naught by x1 minus x naught. So that means what is y1? 2.4829 minus what y naught is 2.4771. Okay, divided by 304 minus 304. Now it is 0.00145. Okay, and next one, of course here we have to take in the middle mark. So in the middle means here y1 minus y naught. Okay, I think it is better to take the values by taking more distance. Here what we have? 0.00145. Next one, y2 minus y1 by x2 minus x1. Okay, so then what we get? 2.4843 minus 2.4829 divided by 305 minus 304, that means 1 only. So then what we get? 0.0014. Okay, next y3 minus y2 by x3 minus x2. Now 2.4871 minus 2.4843 divided by 2. 0.0014. Okay, next is second divided differences. So in second divided differences, what we have to do again, what will be the formula? We have to take these now. So that means here it is x0 comma x1, x1 comma x2, right? Next x2 comma x3. So now here what we have to take? x1 x2 minus x0 x1 by what we have to take? Here these two values means x2 minus x0. Upper value is x2, lower value is x0. Okay, so now here what we get? Simply this one minus this one. 0.0014 minus 0.00145 divided by x2 minus x0, 305 minus 300 divided by 5. That means 0.00, what we got? 4 zeros, yes, 1. Okay, and next here 0, it will be 0. So the next third derivative means what we get here? 0.0001. Now we have to substitute all these values in the formula. Now here x is n is equal to 3 mark and x is equal to 301. Now y equal to y0 means 2.4771 plus x is 301 minus 300. x0 comma x1 means this value into 0.00145 plus x minus x0. X minus x0 into x minus x1. 301 minus 304 into this value. Only we have to take this one and this one. 0001. Next plus x minus x0. X is 301 minus 300. 1 into x minus x1. X is 301 minus 304. So 301 minus 3. X minus x2. 301 minus 305 into this value, third derivative, 0.00001, and the remaining values are zeros. Now here take the calci, 2.4771 plus 1 into this one, that is 0.00145. Next 1 into, here it is 1 and minus 3. Okay, so now here minus 3 means here we will get minus 3 into 0.00001. This is finished. Next, here 1 minus 3 and here minus 4. Minus into minus plus 12. So 12 into 0.00001. Actually we will get it as nothing but plus 0.00012. Okay. Now take the addition, 2.4771 plus 0.00145 minus 0.00003 plus 00012. So the final answer is 2. I got the answer actually, just I am checking my answer is correct. Yeah, 4786. So if you observe the Lagranges and this one, you will get the same answer. So the meaning of this one is you can use any one. If you feel Lagrange's method is easy, then you can use that one. Otherwise this one. But if they mention the method, then you have to take that one only. Okay. So yes, with this the second unit is finished. And in the next class, I want to discuss some exercise problems related to this one. Okay, so with that we will close the second unit and we will start the third unit. Okay, I hope it is clear to you, and if you get any doubts, then please ask me and try to finish the notes. Thank you.